it's always good to look for one, but not all chemistry problems have a reaction that happens. And when there's no actual chemistry that happens, then you don't have to worry about finding that balanced chemical equation, you don't have to worry about stoichiometry, you don't have to worry about any of that. Okay, so in this situation, I think it's always probably the first question you should ask yourself doing any chemistry problem. Is there chemistry happening? And if so, what is the reaction? If not, then what equation do I need to solve the problem as is? And you've got, that's kind of a long written out problem there, but at the same time, if you just look at the first sentence, you know, how many liters of the stock do you need to make 5 liters that is a lower concentration? That should tell you right there that it kind of looks like a dilution problem. You're just diluting, but you're not doing any reaction. So of these 4 variables, we have 3 of them. What is my M1? What is my initial molarity? 20. Okay, so I've got 20 with a dot. Okay, my V1 is what it's asking me for. Okay, it's saying how many liters of that, and the verbiage is, it kind of gives it away. How many liters of my initial concentration? And the word of in math means what? Well, it's multiplication. So just going back to, you know, I don't know, math from eons ago. How many liters of, since this is multiplying, of that, right? And then my my final molarity they give us is it has to be 5.0 millimolar. How do I know that this isn't my M1? How do I know that? Will M1 always be larger than M2? The answer is yes, okay, because for dilution, you're always going to decrease the molarity in a dilution. You're always diluting the concentration, right? Okay, my V2 is 5 liters. How do I know my 5 liters goes here? How come I'm not sure it goes here? How do I know that? Right, it's kind of like tied to that. It says 5.0 liters, that is 5 millimolar. So just alone by that sentence, you can tell the two of them are tied together, right? Okay. Before doing any calculation, would my V1 end up being smaller or greater than 5.0 liters? It's going to be smaller, okay? So for dilution, your initial molarity will always decrease as it becomes a final molarity, but your initial volume will always be smaller than the final volume. So when you're doing a dilution, you're always increasing the volume, but you're always decreasing the molarity. So volume increases, molarity decreases when you do a dilution. All right, lower concentration, but a higher volume. And that's because the moles have to stay the same. So the volume of stock that we need is going to be V1, 5.0 millimolar times 5.0 liters divided by 20 millimolar. The millimolar units will cancel. So we don't have to convert these into molarity. We can just leave them as millimolar as long as the other one is in the same units. Does that make sense? And we did both liters for a unit, and we get 1.25 liters to 2 sig figs, though, it would be 1.3 liters. Okay, so we would need 1.3 liters of our stock. And getting to the next question after that, if only 2 liters of the 20 millimolar stock were available, would it be enough? So if we need 1.3, but we've got 2 available, do we have enough? And the answer is yes, we do have enough. Okay, so yes, we do have enough. Because 1.3 liters is less than 2.0 liters available. life I got a question. Okay, and then the last question there, how would you make it? What if you're in the lab and you need to make this solution? What if you're a field biologist? We'll take like your background. What if you're a field biologist and you collect a bunch of barnacles from the ocean and you take them back and you digest them in acid and you want to find out what's the concentration of some protein in their shell or their flesh inside. I don't know what barnacles actually look like inside, but they're little organisms in a little shell, right? What if you were looking at, what if you had to figure out like how to make, I don't know, a solution of this, what is it, dihydrogen phosphate? That's a pretty typical buffer, for biochemistry. So what if you had to make that buffer to study these barnacles and you want it to be biologically safe for them to survive? I don't know, I'm just making things up, but this happens, right? You collect organisms or whatever it is, maybe you kill a few to study them so you can save the population, right? And you make these kinds of buffers to work with them, right? So how would you make the buffer? How would you make this solution? How would you make this dilution? You would take 1.3 liters of the stock. You want a final volume of 5 liters, so what do? You take 1.3 and add water to it. How much water do you add to it? 3.7, right. So you would take 1.3 liters of the, potassium dihydrogen. So potassium dihydrogen phosphate stock. Okay, and add 3.7 liters of, we'll call it DI water, which is what we typically use. And add 3.7 liters of water to it. So we're not just calculating a number, it's good to think about, well, in real life, what is this, right?